watch any of the videos that I post of things that we're talking about, whether it's notes, whether it's like a review. If it's me up here teaching, I'm taping it for a reason. It is a review or better than just like filling in your notes. Please watch it, all right? I know I've talked to like 15 people who've been out. I don't know if anybody has watched them. Like, they're like, no, not yet. So hopefully they've gone back and done that, but that's gonna be the best way to help you, all right? And if something in class like was confusing, you can always go back and watch it even if you were here, right? It's there. So it is a good thing. Just take advantage of it. Use that resource. You know, it's something that I take the time to do. I know that a few people have in the past used it and they said it's been helpful. It's a lot better than just looking at the notes and filling them in, okay? So always make sure you're watching those. So I want to do a little bit of marking on this table before we actually start filling it in. So this is slide 78. And we're going to be looking at, so here is going to be groups, and I want you to put 1 through 18. Because we're looking at all the groups, not just the valence groups, but all the groups in that periodic table. And then to help you remember the mass number, is that the big number, don't shout it out, or is that the small number on your periodic table? What's it gonna be, Charles? It's the large one. So I'm just gonna put big, right? It's the big one. And what two things does it include? Like, what's it actually counting up? What two subatomic particles? Audrey? Very nice. So I'm going to put P plus N, because I know that that's counting the protons and the neutrons. Or you can put it up there, wherever it fits. I'm not sure if yours is, it's not blocked out this time, that's good. All right, moving on to the atomic number. If the mass number is the big one, it's the small one, good. And what subatomic particle is it counting up? Protons, electrons, neutrons, what combination of that? Maybe. Somebody else. Come on. The other Charlie? All right, what is it? Just the protons. So, if we subtract the mass number from the atomic number, that's going to equal our number of neutrons. So once you have this number, subtract it from this number, and you get your neutrons. It's the only way to get neutrons. There is not a number on that little square for the element that has the number of neutrons. That's the only way to do it. All right, you have to subtract them. Okay, and then we know that the protons is going to be the same as our atomic number. So whatever the atomic number was, that's going to be our protons, because that's what atomic numbers mean. So the small number, atomic number, and protons, it's all the same thing. The big number, the protons plus neutrons, and it's the mass number. Those three things go together. Okay? Total electrons. If this atom is neutral, what are they also going to equal? So on the periodic table, we're assuming all of these are neutral. They haven't given any electrons. They haven't become an ion yet. They haven't done anything like that. All right, so how do we find our total number of electrons if it's neutral? Sure is, so put an equal sign. Now, valence electrons, those are just those groups 1 through 8. Those tall columns. We're being a little discriminatory against those poor little short stack of columns, right? Those transition metals, we don't include in the valence. We're just looking at the tall groups, right? And then the Lewis dot structure, obviously, I don't think we need to have any little hint for that one. But these things are important. Have those on there. Number 1 through 18 for the groups. Big and protons and neutrons. Small protons. Minus equals, protons are the same as atomic number. Protons equal total electrons, and 1 through 8. All right, so let's see how we're doing with this stuff. All right, so find chlorine. And I'm just gonna randomly call on people. So make sure everybody has their periodic table out and find chlorine. And once you've found it, you should be able just to go through and be able to answer if I call on you on any of these. So chlorine, what period? So we're talking like the row. What is that gonna be, William?
3.
Okay. All right. What group? 1 through 18. What group does it fall in? What do you think, Abigail?
17.
Okay. What is the big number? And remember to round. Anthony, do you have that one? The big number for chlorine? Wait, Stewie, do you have Stewie?
35.
35? I thought you were right on it, Anthony, that's why I called on you. Do you have the small number, the atomic number?
17.
Okay. And we need to do a little bit of math here. 35 minus 17, or our protons plus neutrons minus protons will leave us with just our neutrons. What number is that going to be? It's not the friendliest subtraction because you have to borrow. What do we have? If you're not sure, you can always put it in calculator. But Audrey, what do you got? 18. Sounds good to me. And then check yourself, right? 7 plus 8 is 15 plus 1 plus another 10, so yeah, 35. Okay. What's the number of protons, Breeze?
17.
Good. Because the atomic number and protons are the same. And then what's the total number of electrons? What do you think, Dylan? What's the total number of protons? Or excuse me, total number of electrons? This one that we're on. We're on chlorine. Okay, so you should be with us. Okay, so what's up here? What does this say? Protons equal total electrons. Okay, so if protons are 17 and they equal, huh?
Is that 17?
It is.
Okay, that would mean that all that cancels each other out and it's neutral.
Right, exactly, which is why they equal each other. You've got that exactly right. All right, valence electrons, or what valence group? What do you think, Caitlin? Valence group 7. Okay, and for the Lewis dot, we draw the symbol, right? So Cl, and then we use however many valence electrons we have. So right, top, left, bottom, right, top, left, and so we have one last chlorine, right? Or one last electron. So if we had one more, that would make it full, right? So it's only one away. So if it would gain a negative, what ion would this actually form? If it gains a negative. So chlorine's always going to form this ion. Audrey? It's going to gain, yep, it's going to be a negative and it's going to gain 1, so it'll be a -1. All right, so that's how the dot model can kind of help us. 8 is that magic number, right? That's the octet that we're trying to get to, that full valence level. So 2, 4, 6, 7, we're just 1 away, just put the 1, right? And that gets it full. And that is the goal for all of these, all right? So this is, the dot models help you to kind of visually see how many electrons do you need to get it to be full, okay? All right, let's take a look. Are we here till the
We're fine.
40? Okay, oh, we're okay then. All right, let's take a look now at oxygen. So find oxygen on your periodic table. So find O, right? And so there's a small number 8, and there's a big number 16. So kind of keep your finger on there, right? All right, so what period is oxygen in? So you're looking at those numbers along the side of your table, right? And you're gonna see what matches that. Owen, what do you see?
It's 2.
Okay? And then what group? 1 through 18? Stewie?
16.
All right. And then for what is the big number? Dylan, what's the big number for oxygen?
18.
18?
Wait, what? 18
Oh.
or 16?
Yeah. It is kind of hard to say. I think it's 16.
Okay.
Yeah. And if you ever are looking, so the 6s and the 5s are a little bit difficult. If you ever need help interpreting one of those, like on the quiz or something like that, come and ask me, okay? Just to make sure that you're seeing it right. Because I know that they kind of blur together, those circles kind of blur. Well done. All right, so give me the small number, Selena. What is the small number for oxygen? Not a 2. What's that small number up above the O?
8.
Yep. Very good. All right. Now, how am I going to find the number of neutrons? You got it?
You subtract 16, 8.
Very nice. Very nice. Well done. Okay. How many protons? Let me see. Cheyenne.
8.
And how did you do that?
Protons and protons.
Very nice. All right. How many total electrons, Michaela?
8.
Okay, because they're going to equal. It's neutral, just like Dylan said. If it's neutral, they cancel each other out. And so that means you have to have an equal number. Who have I not called on? I feel like I've called on almost everybody. Maybe not. Cole. How many valence electrons for oxygen?
6.
Valence group 6. And then the dot structure. How many electrons or how many dots are you going to have around that? Rory.
6.
Okay, so oxygen, and you have 1, 2, 3, 4, 5, 6. So to make this satisfied and that full octet, it needs 2. So this visually lets you see it's going to gain 2 negatives, so it's going to be a negative charge, and it needs 2 of them, so it's a negative 2. Not subtracting 2, we're talking gaining negatives. You guys feel pretty decent about that? Tomorrow, what we're going to do is going to be very similar to this, okay? So you'll get lots of practice, and that'll be a great review for the unit quiz, which is hopefully going to be Friday.